So let's talk about big Endian versus little Endian format when storing values on the ARM Cortex-M processor. So if our value to store is 90AB12CD, then in the big Endian format, the most significant byte is stored in the smallest address. So 90 goes in address 1000, AB goes in the next address, 12 goes in the next address, and CD goes in the highest address. For the little Endian, it's the other way. The least significant byte is in the smallest address. So CD goes in 1000, 12 goes in 1004, AB goes in 1008, and 90 goes in 1000C. So let's go and check what it's like on the STM32F3 Cortex-M processor that I'm running. So let's take any address. Let's take the first address of flash. So the first address of flash has the value 0x2001 followed by 4 zeros stored inside it. Now let's go and check what the memory looks like. So I'm going to open the memory window, going to Window, Show View, and Memory. Inside here, I'm going to add the address that we want to see. So if we start reading bytes from the word, so this is a 32-bit word, so we start reading bytes, you'll see that in the smallest address, we have 00. In the next address, we have 00. In the next address, we have 01. And in the last one, or the highest one, we have 20. So which means the most significant value, 20, is stored in the highest address. So which format is this then? If the most significant value is stored in the highest address, then we are in little Endian format. So on the processor that I'm running, which is an STM32F303RE Cortex-M processor, we are storing values in little Endian format. And this is really important to know when you're trying to look at data in memory. If you look at the data in memory and start interpreting it as a big Endian format, you'll get it all wrong. So you have to make sure you're interpreting it as little Endian format.